So let's see its principles. We use Singleton design pattern to ensure that a class has only one instance per application, and uh, it is used to provide a global point of access to that Singleton object to other components in application. So there are various scenarios where there is a need that throughout our application there should be um, a single object of some class in the JVM's heap memory, and all other objects in the JVM heap should refer to that single object, the singleton object of that class. So let's see one of the scenario. So suppose we have to develop a cab booking application where the availability of the cabs should be managed by a single component, and multiple cab booking app instances must check the availability of the cabs via above mentioned single cab availability component. So let's try to see this via some code. So I talked about um, a component which should be responsible, or a class which should be responsible to tell us about the availability of the cab. So say um, I have a bunch of cabs, a pool of cabs, and I have to check whether there is any available cab at this moment. Then I must reach out to this class to get that information. And so and it should maintain a single object per application, so that I always get the true data, the right data. So as we know, like if you have to make sure that there is a single object of this class, then obviously I'll have a private constructor, so that no other class can create an object of this class. And I will have a static reference to this class, and it's going to point to that single object which will be created from this class only by calling this private constructor. So if you see this static method which is get instance, so in this method I am checking that if my cab manager, this reference is pointing to null, then I am going to create an object of cab manager by calling the private constructor. This class has also got some instance level variables, such as total cabs of type int, reserved cabs again of type int. So in the private constructor I am assigning the um, number to this private instance level variables data members. So I am saying that total caps is equals to 2, and at starting my reserved caps will be 0. And when somebody has to get the instance of this class, they have to call this get instance method. And apart from that, I'll come to this. There are few instance level methods also, like reserve cap, wherein I'll check that if there is any available cab, I'm going to increment the count of reserved cabs and return true, or else I'll return false. And when any cab will be done with its journey, then I'm going to return that cab to the pool, and I'm going to decrement the count of the reserved cabs. So now let's see this cab booking class. It has got a method called bookcab, wherein it's going to call this cab manager dot get instance, get the object of cab manager, and as I said, there will be only one object that will be created. If some other um, like object of cab booking calls this book cab method again, and if it goes to this get instance method, then I at the second instance my cab manager will already be uh, pointing to object of cab manager, so it's going to just return back the same cab manager object, and no way I'll be able to call the constructor of this class to create a different object of cab manager, because its constructor is private. So after getting the cab manager object, I'm going to call this method reserve cab, and it's going to see the count of total cabs minus reserved cabs, and as I said, if it is available cabs are available, which is it is greater than 0, then it's going to increment the count of reserved cabs and return me true. And if I get a true as the answer, then I'm going to simply print this cab booked, or if I get false, then I'll say cab unavailable. So let's try this out. There is cab booking test app which I have created. So here I'm going to create 3 instances of cab booking class, and I'm going to call this book cab method on the cab booking instances. So when I'm going to run this, I'm going to get the answer as cab booked, and cab unavailable, because when I call this for the first time, it's going to get an object of cab manager, and it's going to try to reserve the cab. So the first 2 cabs will be booked because my total cabs count is 2, but at the third instance this will return me 0, and it's going to return me false, and hence I got this answer as cab unavailable, which is fine. So now I have successfully tried to ensure that there is only one object of cab manager in my JVM heap, and other components, whenever they try to create or get this cab manager object, they get the same instance. But there is something to think more on this. So if I go to this cab manager, and you can see that I'm initializing this cab manager lazily, so that like when the first request comes, I check that if it is null, then I create a new object of cab manager and I return that. So now suppose if 2 threads try to get the instance of cab manager at the same time. So the thread 1 comes here, checks this if cab manager is equals to null, and it will find it null, and at the same time the second thread comes and checks this condition, it will also find it null, and both the threads eventually will create their own cap manager instance. So at the end I'll have two cap manager instance, which I don't want. I want only single cap manager instance in my JVM heap. So this can be done if I want to take the same approach and I want to instantiate this cap manager lazily only as per the first request. Then simply I can make it synchronized so that um, this method is a static method, and if I introduce this synchronized here, a class level lock will be acquired, and only one thread will be able to enter this method, and it's going to create a cap manager instance and get that. The second one, when it's gonna come, it won't find it null, and it's going to get that same single cap manager object. A few more things to consider here. So I have few more shared resources in the class which are at the instance level. So in case of multi-threading, I need to consider these things also. So either I can make this instance level methods synchronized, and so that by default object level lock will be created when any of the thread tries to enter any synchronized instance level method, and all other threads which will try to enter these instance level synchronized methods, they'll have to wait, they'll be blocked. Or I can make use of synchronized blocks over the critical section of the code inside this method which is making use of the shared resources, and in the synchronized block I can take a lock over the object of cap manager. So yeah, that was the scenario use case, and how we should go about to make sure that there is only a single object of a class in the JVM's heap, and all other objects should have a global access point to get that single object, the singleton object. So that was the theme of singleton design pattern, and in which all scenarios you should make use of it. So thanks a lot friends for watching this, and hope you must have got the basic understanding of when to use the singleton design pattern. Thank you.